Okay, good evening. Welcome to
Family Math number 331.
FamilyMath331. So, for your math club at your school, they gave you a packet of a lot of problems, right? It was like 200 problems or something?
Yeah.
And we were just kind of taking a look at some of them, and one of them was a really neat counting problem, and I thought we would do it as a family math project. And actually, I want to talk about 3 different ways to approach a problem like this. So, you ready for the question?
Yep.
In the 6x6 array of squares shown, so they give a picture, I built a little array out of snap cubes. 2 squares are adjacent if they share a side. Okay, so what does that mean?
So like these two here.
Those 2 are adjacent. Okay, good. Show me 2 squares that are not adjacent.
Well, this square and this square.
Okay, if squares touch, are they adjacent?
Yeah. Well, but they can't touch. They have to touch at more than one point.
Oh, interesting.
Because like this square and this square aren't adjacent.
Okay, those are diagonal from each other. All right. So, I lost where I was. They're adjacent if they share a side. What is the probability that 2 adjacent squares, chosen at random, are not the same color? Pretty good question.
Yeah.
So we're going to talk about 3 different ways to solve this problem, but that's what I came up with, 3 different ways. But I'm curious if you guys have any thoughts about this before we dive in.
Well, we can see there's 6 white squares. There's how many? There's 30. There's 30 black and 6 white.
Okay. That's right.
Yeah.
So what do we need to do with those black and white squares?
Well, we could. There are more black squares than white squares, so the probability, it's going to be bigger. I think it's going to be bigger than a half.
The probability that 2 adjacent squares chosen at random are not the same color? You think it'll be bigger than a half?
Yeah, because
Okay.
more than half are black.
Okay. Interesting idea.
Hmm.
What do we need to do to calculate the probability?
Well, we need the good outcomes over the total outcomes.
What does that mean?
We can figure out the total number of combinations of 2 adjacent squares.
Okay.
And then we have to figure out how many of them are different colors.
Okay, yeah, that's great. That's a great thing to say. We need the number of different colors. Adjacent squares. I didn't have a lot of room for that. Over the total number. Okay, so we've got to find the total number of different colored adjacent squares
The total number of adjacent
and
squares.
the total number of adjacent squares. Yeah. What do you think? Is it going to be more than a half or less than a half?
Well,
This probability before we dive into it?
I think it'll be less than a half. I think it'll be more likely for them to be the same color.
Okay.
And because there's more black than white,
All right.
should be less of a probability that they're different.
Okay, awesome. All right, so I'll turn off the camera and we'll find the first approach here, okay?
Okay.
Alright.